Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to our Thought Leader series, Unlocking the Formula for Energy Excellence. My name is Megan Purdy and I'm from Engineers Australia. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past, present and emerging. Before we get started, I would like to acknowledge that today's webinar has been hosted with Engineers Australia's industry partner, ABB. ABB are pushing the boundaries of technology to help build smarter, greener cities of the future today. By innovating how people work, live and move, ABB is creating solutions that enable its customers to reduce their carbon footprint while maintaining operational excellence. As a leading provider of electrification solutions for industry, infrastructure and transport, sectors that account for 3/4 of global energy consumption, ABB are a key enabler of low carbon society. Through ABB's technological and digital innovations, they support customers and partners with solutions that address emerging trends such as urbanisation, digitalisation and the shift to electricity and sustainable energy. Now today, we'll hear from our speakers, followed by our live audience Q&A. So I encourage you all to please send your questions through to our speakers via the chat box. I would now like to welcome Lisa France. Lisa is an experienced senior executive and global project leader with more than 25 years of demonstrated achievement across engineering, environmental services and corporate affairs in the resource and energy sectors. Lisa works for Sorbonon Jurong SMEC as National Energy Manager, where she assists clients around the world as they decarbonise their operations and deliver renewable energy solutions. Her time as a Member of Parliament in Queensland and service as Assistant Minister for Natural Resources and Mines, as well as Assistant Minister for Finance, Administration and Regulatory Reform, has given her valuable insights and experience in financial, reputation and risk management, and the opportunity to lead a number of groundbreaking energy initiatives. Please join me in welcoming Lisa France.
Thank you, Megan, and welcome again to our viewers. I'd now like to welcome our first speaker, Milad Mostafavala. Milad is a Senior Product Manager in Electrification Smart Power Division at ABB and a practicing registered Senior Electrical Engineer with expertise in energy distribution and electrification. He's been consulting with clients across small, medium and large enterprises, including commercial, industrial and government sectors in Australia, Europe, the UK and New Zealand, supporting them to incorporate electrification solutions. Milad shares a passion for electrification, energy transformation, digitisation and efficiency. Please welcome Milad Mostafavala.
Good afternoon, ladies and gentlemen. Thanks for attending our webinar for today for unlocking the formula for energy excellence. What I have prepared for you today in terms of the agenda is around 4 major items really in terms of how energy management within electrification can assist in becoming energy efficient. So that will be the first section of our presentation today that I have prepared for you. In the second section, I will be talking about how energy efficiency can improve carbon footprint reduction. And in the third section, I will talk about how important is finding correlation between energy consumption and other energy-related data. And lastly, in the fourth section of our presentation today, I'll talk about how ABB's energy management solution is capable of monitor, detect, and analyzing energy-related data, which in this section, my colleague, Mr. Shun, will be able to discuss further details around the Insight Energy Management solution. So, last year when I was invited by the Energy Efficiency Council to provide this presentation for Engineers Australia, I presented the situation with respect to the current challenges within the energy landscape. And what we discussed was around consumers having concerns in terms of cost. They are trying to obviously reduce their energy cost. They are trying to become more sustainable, which means they are trying to reduce their carbon footprint. And at the same time, they are having more connected devices, such as the electric vehicle infrastructure, which are calling out for reliable service and constantly connected services. And the landscape since last year hasn't changed in terms of our energy challenges. This situation is still valid to date in terms of the challenges that consumers are facing. We have even gone a step further in terms of our power system. Thankfully, our power system is more decentralized now. There is lots of battery energy storage systems implemented within the grid. Additional solar generation has happened, and lots of wind generation that has been signed off or is ready to be connected as well is taking place. So the power system is obviously moving a step further compared to when we spoke last year. And with respect to the challenges of the current situation with the power system, obviously that shift is progressing quicker and faster. And it's really moving towards the you know, idea of what I would like to call it as Internet of Energy, which would be the idealistic view where the load can communicate to the generation across the transmission and having an interconnected system within the power system. Um, that will definitely create some needs for a power system of the future as well. Some of these needs are around frequency regulation. Obviously, a decentralized market platform would be very, very much needed. Regulatory requirement would need to change as well. Load management would become crucial too. In terms of managing voltage and reactive power, it would be quite crucial. So there would be quite a number of needs that the power system will look like in terms of the direction in which we are traveling. If we transpose that picture and if we sort of look into the energy market situation, trying to analyze what's going on within the energy market, we can say cybersecurity is one of the major items. Additional investment is definitely required. There is a huge amount of renewable penetration into the energy market. Engineers, lack of engineers, there was always lack of engineers or professional to be able to help us, in this journey was always the case. And the aging transmission infrastructure is also another need that the energy market is facing. So in essence, if we sort of take that picture for the power system and the picture for the energy market and the situation with the consumer, we can come across a common sort of item that all these stakeholders are looking for. All of them are trying to achieve sustainability. All of them are trying to improve their energy usage, trying to avoid any unnecessary penalties, trying to reduce their operational expenses, and eventually trying to reduce the energy consumption. And technically, that can address the consumers and their needs and challenges, the power system needs and challenges, and equally the energy market needs and challenges. And the centerpiece of this situation would be the digital energy management that can address these needs and challenges simultaneously for all the three stakeholders involved. And how can the energy management assist becoming energy efficient? Well, with the introduction of various technologies in terms of the battery energy storage, in terms of solar, in terms of wind, it can resolve that complexity essentially, and it can create that ecosystem from the generation to the transmission to the load. And at the same time, it can create a sustainable sort of improvement in terms of greener energy, and at the same time, it can help and assist with the power quality as well. And it really develops opportunities. And we believe that's how the energy management within electrification is able to assist with becoming energy efficient. Now, the second question that we had in our invitation today for you was the correlation between energy efficiency and carbon footprint. And what does that association look like, really? Um, there's a lot of challenges in terms of becoming sustainable, and obviously there is need for everyone that they want to reduce their carbon footprint. But the question here is really how to get there and how we are able to achieve that sustainability goal within this complex journey. There's going to be lots of hurdle, and there's going to be lots of problems, but some of these issues that corporate clients, customers, plants, engineering managers are facing at the moment is really understanding where and how a business is consuming energy. So that's the first step. Second part is being able to continuously monitor that energy consumption, and trying to do that power quality monitoring, specifically when you have variety of sites or variety of locations with lots of different users, and having a bird's eye view around that. Not to mention optimizing the health and performance of the asset as well to reduce your operational cost is also a challenge, and it's correlated to the sustainability factor. Obviously, lots of corporate accounts and clients and customers are trying to integrate as many as possible. They're trying to connect as many renewable energy sources as possible, and they believe that that will help them with lowering their carbon footprint. So finding a sustainability solution that is cost effective is becoming a challenge and is becoming a bit of a dilemma here. Here at ABB, we believe that there is a correlation between sustainability and resilience. If you are able to improve one, you are able to do the other one simultaneously, one vice versa. And resilience is all around improving your downtime, trying to ensure that you are able to predict the issues that causes and detect them proactively, and being able to reduce that downtime that occurs within your facility, your electrification distribution solution facility, and at the same time being able to monitor and optimize the use of energy for your plant and power system and electrical asset. And imagine how that can then help in terms of direct translation of improvement from your active power, your reactive power, and having that directly translated into a tangible value in terms of your carbon footprint and in terms of your carbon emission, and being able to improve that level of power, improve that level of efficiency in terms of your energy consumption, will have that direct correlation in being able to provide a value in terms of your carbon footprint reduction and improvement in your carbon emission that you are hoping to achieve. And that's technically how energy efficiency can improve carbon footprint reduction. So it's all around how to monitor your energy and being able to benchmark that, and then later on being able to focus on the sort of electrification component of your facility, and within the electrification part then being able to have tangible values that you are able to reduce and improve on. So what is then the correlation between energy data and energy efficiency, you might think with yourself at the moment. Last year when I presented, I spoke about these 4-step journey that will assist any planning engineers or any consultant or any client who would be able to start their journey across the energy efficiency. And those 4 steps are starting with measurement and verification. So that's your benchmarking technically. Looking into power quality monitoring as a second step. And third step, to be able to optimize, which is plan, do, check, act. So that's what we call these days as ISO 50001 standard that some clients are getting on board more often, especially in Australia, to have that ISO 50001 certification. And obviously, last step is all around forecast and predicting the behavior within your electrification component. And this is how the correlation between data and energy efficiency is able to be powerful enough to assist you. Imagine the amount of information that you're able to achieve, or you're able to gather in terms of monitoring different values in any given plant. That could be a building, that could be an industrial factory, that could be a data center. It could be any sort of facility that's connected to the grid. And further on, being able to get sort of a bird's eye view within power quality as well, to understand where it is that you are able to improve and ensure that you can have a better performance within your plant, or even being able to compare your grid connected usage, compare your grid connected sort of power versus the solar, versus the renewable, versus the sort of battery energy storage one that you are using, and being able to compare these two in terms of your analytics. So it's all about data, and it's all about being able to read and measure those data, and then being able to compare them and make sense out of them to be able to make a sensible decision. So that will bring us down to the concept. So the concept here is really around monitor, detect, and analyze. So what we mean by that is technically you would be able to benchmark, then optimize, and take the appropriate action to be able to provide for this. And digital energy management is a sort of a tool that you are able to utilize or incorporate to be able to take you through these 3 steps. And to answer this problem within the industry and within the market, what we have is one of our solution is the ABB Ability Energy Manager, which is able to provide those 3 pillars that we talked about in terms of detecting, monitoring, and analyzing the performance of your plant or facility, whatever it is that's connected in terms of electrification. So just to paint a more accurate picture in terms of how such tools such as the ABB Ability Energy Manager is able to assist, whether it's you or the facility people or the end client, or in terms of your consulting design. These are some of the additions that the tool is able to incorporate and provide as performance for your facility. And it can describe this sort of activity status too, or even a very simple figure in terms of how the usage occurs within a dedicated sort of time frame, whether it's a week or a month or a year. For those of you who are just like myself, quite an engineer and very deeply rooted in technicality, you may ask how the architecture to implement such a energy management tool can be sort of laid down. Obviously, you are able to provide for that in terms of your medium voltage switchgear, your low voltage switchgear, and you are able to sort of incorporate them across to be able to monitor all those assets, all those switch gears across from the platform such as that. And you can also report this through API back if your organization or your end client's organization is having a bit of a sophisticated CRM or tools or softwares that they already use. You are able to provide this as an electrical input to that section of their facility. A question that you may ask is also in terms of third party. So we are also able to provide for that through another solution that we call as eKit, and that would be for non-ABB asset and switchgear that's able to do the exact same thing and assist you with those 3 steps in terms of monitor, detail, and analyzing the energy-related data. We have done this for quite a number of projects in terms of small, medium, and large enterprises, both in terms of commercial and industrial, and we have been able to accommodate this for building segments, for e-mobility segments, for utilities, for food and bev, etc., etc. Now, one of the sort of less talked about and less spoken items, which is quite powerful, is the sub-distribution within the residential, commercial, or industrial application. And one of the major sort of items that I'm being asked regularly is how we would be able to sort of do the sub-distribution part of the story. And hence, that's where my colleague, Shun, would be able to provide some further bird's eye view with one of the energy management solutions that we do have and we do offer in ABB, that is called Insight. And I would like to pass on with that to my colleague.
Thank you, Millard, for your input. I'd now like to welcome our second speaker, Shun Mizuta. Shun is Australia's Product Marketing Manager for ABB's energy distribution product portfolio. In this role, he's responsible for business development of residential current device, miniature circuit breaker, fuse gear and switches, and the energy management system. He has experience working in ABB Japan for 7 years in similar roles and working for ABB Australia for almost 5 years. He's passionate about protective device of DIN rail products and digitisation of sub-distribution board with ABB Energy Management System. Shun Mizuta.
Okay, thank you, Lisa, for the introduction. Let me start with a solution of Insight features. Insight is designed for the sub-distribution board. It can collect the data of what's going on in the sub-distribution board in terms of the current energy usage or power, and make it possible to visualize on its own platform. So it can do the monitoring, detecting, and analyzing of those 3 pillars. Let me get on to that and explain how we do it. This is the system architecture of Insight, showing ecosystem of it. We have 2 solutions, one called Insight 1.0, which is on the left, and another is Insight 2.0 on the right. As you can see on the left, Insight 1.0 has a control unit of 8 modules with it is a comprehensive solution. It has all the functionality already integrated in there. Whereas the Insight 2.0 on the right is designed differently, slightly differently. It is a modular design. It has different kinds of the add-on modules, which go attaching onto the left of the device, up to 5 modules, 5 functions. The parameters, measurement parameters is like this. As you can see, all the main currents, voltage, energy usage can be given both SU100, SU200 controller units. And maybe only the big difference is the number of the branch current sensors can be attached on. What is this? This is up for the branch circuit monitoring. Sometimes we call it the micro monitoring. It will have a small current sensors which are add on top of each MCB or RCBOs, so that controller unit can measure the current measurement. So 96 current sensors can be attached to inside 100, whereas 32 circuits for the SCU 200. And all sorts of the Modbus protocol devices or Modbus TCP IP devices can be connected to both inside 1.0 and 2.0, which means all the energy usage or the power factors or total harmonic distortions or individual harmonics, all sorts of the power quality parameters can be visualized. The M-bus devices can be connected to SCU100 only, not for the SCU200. Sorry, the other way around. M-bus devices can be added onto SCU200, but not for the SCU100. Also, pulse input devices can be connected to both devices. Okay, this is a great way of showing what it can be connected. Let's go with inside 2.0. You got the control unit in the center, and if we want to connect the current sensors, you can add solid core sensors or open core sensors like this with using the ribbon cables. And there is a smart auxiliary contacts that can be connected as well. Here is the example of energy meters modules. You can add multiple modules like this, and on the left you're seeing this is power supply for those modules. If you want to have M-bus, wireless M-bus modules, you can also do that like this. And inside 2.0 can be connected up to 16 Modbus RTU devices like this, which includes EV chargers or PV inverters, energy meters or power analyzers, or MCCB like this. Here is another example. You can add up to 16 devices of Modbus TCP IP like this. Inside controller has a Wi-Fi connectivity so that you don't need to have a internet router or there. And it also has a extension memory slot like this for the SD card. Let's look into inside 1.0. You got 8 module with control unit. And as I said, this is a comprehensive solution. It has a capability of connecting 4 external cities, line 1, line 2, line 3, and neutral. And if you want to measure the final sub-circuit current, then you can also use these solid core, open core sensors. And in terms of the auxiliary contacts, you'll be using the I/O module device like this. Again, Modbus RTU devices can be connected up to 16 devices. And in terms of the Modbus TCP IP, you can connect up to 12 devices. With Inside 1.0, it has a functionality of connecting multiple control units and configuring one of them as a master device and the rest as a slave. So for example, if you have multiple energy meters in one project and you want to monitor them, you can connect multiple energy meters like this to the slave unit and up to 16 devices. And by using Ethernet switching, you can connect multiple slaves as well. So 12 slaves can be connected through the Ethernet like this. The one thing to note is the slave devices will log the data. However, the master device it can visualize only the real-time values only, meaning it's not logging the data over there. This is an example of, say, if you have a multi-story buildings project, and then you can have each slave unit on floor, or you can segregate as by area, and you can actually connect up to 192 energy meters. Okay, that's the quick intro for the inside architecture and ecosystem. As you can see from this picture, inside controller unit has its own web user interface, which I'm going to introduce next, but it can also put out the data to cloud-based solutions like Milad was explaining ABB Ability, or you can use a SCADA for that. But the inside can be act as a sole solution, or it can be act as like that gateway for the talking to the upper system. This is an example of the inside dashboard. It is designed in an intuitive way. You have a menu on the left, you have a pull down. It doesn't require any instruction that to do any configuration here. But one thing to mention here is this is a dashboard. You have so much freedom to change the widget. You can add on the widget also. You can change the size of it, or you can make it smaller. If you want to add more dashboard by different load or different tenants, you can also make that customized dashboard as well. Okay, here's a good example of the detecting, analyzing by Insight. Insight actually can do benchmarking. So Insight will the measurement of two different devices in the same time interval, or compare the two measurements of one single device in two different time intervals. This is a quick way to find the anomalous currents of voltage, power, or energy or frequency, or those parameters you're measuring. So look on the left. If you start seeing this kind of the current, for example, going, running more than usual, then obviously you want to check what's going on with the system. It works in the other way around. If you're seeing the current or the value so much lower than usual, also you want to check what's going on with that. And there is a programmable alarms and events that will be logged in the Insight. Let's look into other examples. Okay, so let's look into this one. Let's look into the left one. Here is the visualization of the graph. For example, you set a threshold at certain value. Let's say this is a current of the main circuit. You set a threshold by programming it. And on the right, here is your setup. Let's see here. If the one of the current sensors are reading the current more than usual, then that means the main circuit is also measuring the current more than usual. And this data will be sent to the control unit like this. And what you see next will be on the left, you'll be seeing the reading going more than usual, going actually crossing over the threshold. And by hitting certain duration of these anomalies, the Insight will start sending the data. This is just following the previously set if-then function of the inside. So what it is doing now is sending the action program to the, for example, to the shunt trip, so that the shunt trip will, let's see here, okay, shunt trip is now shutting down the MCB, for example. Then now current will be going back to the normal. But it does show on the left graph. So now the main circuit is showing the current flowing normal values. Okay, so this is one of the example. If you set the if and then function, you can do this sort of the automation all by inside program. Coming back to the summary of inside, with the perspective of the perception of the monitoring, detecting, and analyzing. Inside has parameters, main circuit, branch circuit, all sorts of energy parameters, power quality parameters can be measured by the device and visualized by inside. Okay, and logging those data locally, but it can also export those data to the upstream device or export the historical data in Excel format. And connecting third-party Modbus devices such as EV chargers, solar inverters, MCCBs are possible. Inside also can become a gateway for the monitoring system of the upstream. But detecting pillar inside can set the alarms with a threshold, crossing up, crossing down, or communication failures. You will get alarms, and those alarms can be sent out by emails to the registered person. Analyzing benchmarking function helps comparing two different values, two different devices of the same intervals, or two different intervals of the same device. You check those values and see what's going on in the sub-distribution board, and optimizing the distribution system with the automation function that we just saw as an example, and storing a full set of data in a single interface to support data analysis for the future and now. That's actually it for the insight. If there is any questions about insight, please ask today, now, so that I can answer it later. I'm passing my mic to Milad to go back to the summary of our presentation. Thank you for your attention.
Thank you, Shun, for your input. I'd now like to welcome back our speaker, Milad Mostafavala, who will now share his insights on the topic. Again, let's welcome Milad Mostafavala.
Okay, thank you very much. Now, let's summarize the presentation today. So, we did discuss today in terms of how our grid is evolving and moving, and we spoke about quite sort of changes that's taking place in our industry at the moment. And that does affect everyone who is within the commercial building sector, in industrial sector, in residential sector, as well as communities, such as the involvement of community batteries or renewable generation within community sort of sector as well. And as an answer, we believe that digital energy management is the centerpiece across all these segments and can accommodate the relevant changes that's taking place and that's shaping the sort of new revolution that we are facing, and it can accommodate those items. In terms of providing energy excellence for a variety of different segments, to summarize some of the factors that you can consider within a commercial buildings types of application is being able to provide for islanding, load shedding, peak shaving, adaptive protection, improving in power quality is some of the items that as engineers you are able to provide within a commercial building types of application. In terms of utility, water and data center application, equally having or designing solutions or systems which are able to provide for demand response, or able to provide for automatic transfer switching is very important, that can help and assist with unlocking the energy excellence formula for your end client and for your end customers. And equally, if you want to look at it from a smart distribution application, really, that can incorporate the new technologies or the new loads, such as new installation for EV chargers too, you are able to equally incorporate these factors to be able to have an energy excellence sort of solution presented to your end client. So to summarize, what did we discuss today was, first, we spoke about how energy management within electrification can assist becoming energy efficient. We talked about the consumer challenges around the industry, power system, and energy market challenges that's shifting across. And we talked about the fact that everybody is trying to become more sustainable, and everybody is trying to reduce their energy consumption. And the centerpiece for that, we believe, is the digital energy management that can assist. We also talked about the correlation between sustainability and resilience, and we uncovered how energy efficiency can improve the carbon footprint in any sort of electrification network or power distribution. And on the third item, we talked about the 4 steps that my colleague, you guys, can utilize to get on board on the energy efficiency journey, and being able to have tangible outcomes in terms of making your clients more efficient. And lastly, we talked about some of the solutions that as ABB we are able to introduce, or we have created, to be able to address these items and these sort of problems within the market. And ABB Ability Energy Manager is one of them, and obviously Insight for sub-distribution is another one that's able to provide that 3-pillar factor for you to be able to detect, monitor, analyze, so technically benchmark and optimize and take action in terms of becoming more energy efficient for your client and for your facility. And with that, I would like to thank you for your time today. Please feel free to scan the QR code that you can see from the screen. We do have a dedicated landing page that can assist you if you are looking for having additional information around what we presented today. And we will be running further in-depth webinar later on this year that can sort of describe the details of the solution that we talked about today. So feel free to scan this. And with that, I would like to thank you all.
Thanks very much, Malad and Shoon, for your really interesting presentations here today. It's now time for our audience to get involved. Please ask our speakers questions via the chat box, and remember to say if the question is for Malad or for Shoon. Thank you to everyone who submitted questions while registering for today's event. I'll start with these questions first. Malad, the first question is to you, and there's 2 parts to this question. It's from Oscar in Western Australia. How is current technology being used to increase energy efficiency is the first part. And second is, what are the trends shaping the future of energy efficiency? Over to you, Malad.
Sure. Thanks a lot, Lisa. Look, I think the current technologies are not used enough, to be honest with you. I fear that because as humans, we are creature of habits, and therefore our openness to utilizing new technology is rather sort of risk averse, and therefore we are used to repeat the same item or design or technology that has been used, and repeat the same thing rather than starting to adapt or try a new types of technology or system. And that would be the advice that I can provide with respect to what I have experienced in the projects that I've been working with. In terms of the trends that's shaping the future of energy efficiency, um, they are becoming very much data driven. I believe our engineering industry is sort of starting to get on board with the AI technology and starting to see benefit with the AI opportunities, which will start from being able to collect the data and being able to therefore analyze those data and being able to make sensible decision out of those data. So I hope that I answered that question.
Thanks, Millard. I think as someone who struggles to use all the functions on my iPhone, there's probably a lot of education that could go with this new technology. I have a second question here for Shun, which is, why is energy efficiency important for our future? And this one's from Daniel in Victoria.
Okay. Thank you, Daniel. Thank you, Lisa. A good question. If I share our experience of some project, we have been supporting some data center project in Australia for our branch monitoring solution, and it is to make sure the continuous operation of the server racks and the system is running at the most energy efficient setup. And having said that, I say energy efficiency or energy management is more important for the sustainability, not only for the environmental sustainability, but also the reliability of the power distribution, which will benefit our customers after all. And as we presented today, ABB has solutions that can help with those three pillars we discussed today: monitoring, detecting, and analyzing. I hope that answered the question.
Thanks, Shun. I'll move on to another question here we've got from Rajesh in Victoria. Millard, this one is probably best for you. How can we educate end users effectively in energy efficiency projects?
Sounds good. Great question. Great question. Based on my experience and the way I look at this is lots of people are focusing at the proposal stage on what it is that they're proposing. And I think most of the end users, they have a bit of doubt because they constantly look into the proposal within the paper or meeting minutes or documentation that's submitted or presentation. What I find to be very powerful is attempting pilot projects. So allowing the opportunity for the end user to trial pilot projects that can help them with the tangible outcome rather than a submission in a proposal document. And I find that approach becoming very powerful and sort of an encouraging shift within the end user level, even within their own boardroom, because the managers there need to have evidence of investment as well. And the other advice that I have, and I think can be quite useful, is being able to provide return of investment to the end users too, meaning that being able to present to them in terms of what it is that they can get in return if they are willing to invest this much. And those two, I think, can definitely help based on my experience.
Okay. I'm just going to encourage the audience to put in any live questions that you might like to ask the guys. Otherwise, I'll keep pumping through the questions we've got here. So the next question is another two-part question, and Millard, this one will go to you. With the transition period from fossil fuels to future energy sources, what do you see as the biggest challenge? And then the second part, which I'm particularly interested in hearing how you answer, is do you see governments as the principal driver for these changes?
Sure. Quite controversial, but at the same time quite factual and important question that has been raised. The challenges are not few. As I presented, we do have challenges within the energy market, so that could be regulatory challenges. We do have challenges within the power system, that could be transmission related or aging infrastructure related challenges, which would then translate into lack of investment as well within the energy resources that we are having or trying to expand, not just within the battery energy storage or renewable sectors such as solar or wind. So the challenges are not few, but obviously the second part is around what government can do to support as well. I believe there is a sort of a move within the government sector in terms of aligning climate-related financial disclosure framework. And I think that's a very important forward step. There has been a consultation approach within the industry that has sort of commenced and closed in the beginning first half of this year, and that consultation sort of called out for net zero transition plans to be incorporated to financial disclosure frameworks as early as possible. And we believe that technically ensuring that financial disclosure can support the rapid achievement of our emission reduction goals, I think that's quite a key factor there as well, that I can see it's taking place at the moment, and I'm looking forward to see more of that sort of actions as well.
That was a great question from Scott Wells in Queensland. I think I can also add this as an ex-politician out of the Queensland government. I would not encourage people to sit back and wait for government to take a lead in this space. You very rarely will thank them for the direction they go in. We are seeing some amazing changes in the decarbonisation and climate change space, led mainly by financial institutions and shareholders. So it's been terrific to see the changes that have been coming through. Shun,
I would like to just call out my just a credit to my colleagues and friends in Energy Efficiency Council as well, that they have been doing a tremendous job trying to sort of run these projects and propose them in a seamless way, so that there can be good positive outcomes for all of us. So a big shout out to them.
That's great. Shun, a question for you is, how much energy savings can be inspected from the Insight solution that you talked about in your presentation?
Thank you for the question. It really depends on how much energy that you're dumping day-to-day business or your facility. But according to our simulation, that Insight can help to benefit the customer maximum 20% of energy savings on their bills, and up to 15% of the CO2 emissions. So yeah, it's really depends on the situation that you're in, but definitely that will improve the energy efficiency.
Okay, thanks, Shun. Millard, maybe one for you here. In terms of ABB's energy management solution, could you tell us a bit more? You talked about the 3 pillars of detect, monitor, and analyze. Maybe if you could elaborate on that one.
Sure. So The idea around the ABB Ability Energy Manager was really developing a sort of a digital energy management tool to be able to address these challenges and the needs that we talked about. And the tool was sort of created and went through the R&D with the three pillars in mind that's what we talked about in terms of being able to detect and sense electrical related data, and then being able to constantly monitor them without having personnel monitoring those items, and then being able to provide that analytics, being able to provide that gathered information, and being able to watch that and sort of export any items that can assist with making appropriate decision. And that's really the gist and the details of how the ABB Ability Energy Manager has been developed and created. Yeah.
Okay. Millard and Shoon, anyone who wants to have a go at this next question? For me, it's particularly relevant given that I'm dialing in from Singapore and I'm working with my Australian team from here at the moment. How appropriate is the possibility of access from anywhere for any user in the market? Millard, do you want to start that one?
Sure, I'll start, and then if Mr. Shun wants to add to that. So I guess one of the major shifts that I see across the projects that I'm working with is there's constantly problems when the access is restricted, or the situation is in a way that engineers are required to attend to site to do relevant diagnosis or constant monitoring. Also in Australia, we have an abundance of land, and the cost of travel is quite high as well, specifically when there are things to be troubleshoot or things to be analyzed. And since the COVID time too, I can see this shift happening, an appetite being created from clients and customers and large enterprises that they would like to ensure that creating the access for personnel is provided for to their facility, and at the same time they can connect at any time rather than the specific hours of operation. And obviously, when we talk about access from anywhere for any user, we are not talking about opening up your entire sensitive plant or electrification area to everyone. Obviously, being able to constantly and securely managing people's access, but having that pathway and that possibility, I think has been taken quite favorably, and the appetite is ever increasing. Since we have come out from the COVID situation, obviously being in Victoria, we experienced that as one of the longest lockdown that we had, and I think that started to make people and engineers thinking that they should incorporate designs and systems and structures that can accommodate this thoroughly. Thanks.
Okay. Shoon, did you want to add anything to
Yeah.
that one, or I have got another question? Okay.
If I may, for the insight, I didn't include in my presentation that how we can access to the data for the insight device, but it's quite easy. And nowadays everybody has a smartphone, right? So if we just type in the IP address of the insight, you can actually just remotely monitor and even control whatever the program you prefixed for the insight if and then function or for the automation. So yeah, so this remote control or remote monitoring is nowadays it's very common to be used for Australia and other side of the world too. So I can do more technical webinars or something, or a demonstration, even the demonstration I can do for the device installed in the Europe, I can access from here and do the things. So those things are available if you can get in touch with us. I'm more than happy to help.
That's great. And since we've lived through COVID, and now we're seeing such a resource shortage in the Australian market, it's great to be able to do things virtually instead of having to have people based everywhere. So, and thanks for the shout out that you are happy to talk to people about how this can be done. I'll move on to another one for you, Shun. So, can we retrofit the sub-distribution boards with Insight?
Yes, most definitely, and I'm very happy to. Someone is really thinking about how to, actually use this kind of the new technology to the current board, the existing board. The Insight is designed for the retrofitting as well. So as I just did it during my presentation, I showed the current sensors, branch current sensors of the U-shape. I set the open core. That's great for the retrofitting the board because you don't need to unwire anything. And the Insight control unit has a very small footprint as well. So it can install to this board if there's a two module with space. And yeah, so these things will help to retrofit the sub-distribution board with the Insight solution. And also one thing to mention is that now Insight 2.0 has a wireless connection. So it will even help more for the connecting the wireless devices as well.
Okay, and while you're on that topic, Shun, what's the maximum length of the ribbon cable from the control unit to the current sensors?
The maximum will be 32 meters for the ribbon cables that are attaching those branch monitoring current sensors. But now the distance will be shorter depending on how many sensors are mounted on that ribbon cable, and it goes as low as 5 meters if I remember correctly. But we can also discuss on this topic because we are talking about designing the sub-distribution board. So you obviously do not need a 32 meters. We can optimize the number of the sensors and that they confirm the length needed for connecting those.
Okay. All right, Shun, I'll give you a break for a second. Millard, you discussed some of the potential needs of power systems for the future. How important is managing voltage and reactive power and frequency monitoring?
Sure, thanks, Lisa. So obviously, with the shift that we are having within our power system becoming more dynamic, there is definitely a vast amount of necessity for items that you mentioned. So being able to monitor the relevant rate of change of frequency, being able to constantly monitor those values, and sometimes even being able to react and respond to them. And here at ABB, we have been able to sort of adapt and improve our systems to be able to accommodate these new requirements as per the changes and the shifts, and we have incorporated them within our solutions that we are providing at the moment.
And Millard, do you see potential for energy savings through the detect, monitor and analyze scheme?
100%. There is definitely an unlocked potential because most of the time, one of the questions that I'm being asked is everybody wants to become efficient. Everybody wants to being able to reduce their energy, but they don't know how. And what I sort of explain to them is, first of all, you need to be able to measure, to benchmark what it is that you are using or how it is that you are using. And then once you have that level of benchmark values or datas in terms of your energy, then you are able to take the next step to look into where it is that you are able to improve and reduce and become efficient.
Okay, thank you. And thank you to Amarelli, who's put in a live question. Can we, and this is obviously someone who knows your product well here, can we connect these ABB through IP daisy chain with loop in and out or spanning tree protocol, that if one IP device in the loop stops communicating, the rest of the devices continue communicating?
I'll take that one, Lisa.
Okay.
Well said. That's a great sort of question, and that's exactly the direction that we are taking. So really moving away from the older types of loop in, loop out manner, and being able to provide with redundant communication that's simultaneously is able to talk and communicate. And here at ABB, what we have developed is being able to provide that level of redundancy simultaneously with variety of protocols, not just one. Within TCP, IEC 61850 is another one that is quite famous these days, and we encourage that as well. And not just within one particular protocol that you can remain, but also being able to have redundancy of communication within that particular protocol. So great question, and that's exactly correct.
Excellent. Okay, and another live question here from Sandesh. Is there much similarity between digital energy monitoring and embedded networks? Who would like that one?
I'll have an attempt if Mr. Shun wants to add as well. In terms of embedded networks terminology, not too clear what they mean. If they mean that's something around having a supply of multiple premises and sort of loads simultaneously. Look, I think if that's what you mean, comparing with the digital energy monitoring, digital energy monitoring is the first step to be able to go to the next level of being able to provide that level of embedded network that you are seeking, and these two would work together. They would be correlating to each other based on what I think you mean by embedded network terminology. Please feel free to leave your details. We would be more than happy to discuss this with you as well. Thanks.
Excellent. All right, I'll leave that up to Sandesh to put details in for you to get back to Sandesh. Another question here, Millard. Sorry to keep you talking, but just maybe your thoughts on has anyone been able to calculate return on investment values by deploying digital energy management solutions? And I'm happy to tackle this one as well.
Sure. I'll try first. Yes. So in most of the engagement that we do with our clients, we do have this option to provide this calculation. In fact, we do have a tool that we have developed that's able to provide that preliminary values for your customer and clients. If you, as an audience member, if you can scan that QR code that will sort of come across in the live or within the YouTube video. If you can scan that QR code, that will take you to our page that has this ROI calculator tool, and you are able to sort of learn from that how it's working, and you can implement that to your project too, and in your proposal to your client.
Yeah, perfect. Okay. I think for me, based at SMEC and working across a global business, return on investment for anything we're implementing on projects is really important. And we're seeing some fantastic benefits coming through. So we're not finding it a struggle when we do talk to our clients about the return on investment by implementing some of these solutions. I've got another one here. How does a new data-driven approach on energy management differ or distinguish to traditional energy management? Millard, sorry, do you want to keep talking?
Sure. I'll take that one. So perhaps the most important sort of points of differentiation is the data-driven approach. Within the sort of traditional method, the use of data was not as sophisticated as it is now. And there would be a shift further as well, and that would be the predictability shift that will totally distinguish the digital energy management to how the previous sort of traditional methods used to be. And back to what we discussed just now in terms of obviously with you connecting and running this webinar from Singapore as well. The new digital energy management does provide this possibility of access from any location, providing to the sort of any user kind of format, obviously with the ability of managing the user and their level of access to. So I think these are the few shifts or improvements or enhancements that the new digital energy management is able to bring in comparison to the traditional sort of method.
Okay. Shoon and Millard, we're getting close to the end of our time here, but I just want to throw a few more things out to you. We're seeing a lot of changes in the energy space, and it's fantastic. We're seeing clients moving towards decarbonising their operations. We're seeing governments and private clients all make big commitments around going net zero by 2030, by 2050. We obviously have a lot of projects that need to be delivered. I'm just keen, given that you are cutting edge in this energy space, I'm keen for your personal thoughts on how things are moving in this direction around energy transition. You obviously see a very big role that ABB is going to play moving forward. Keen to hear your thoughts on this. Maybe Millard, if you start, and then Shoon can add in.
Sure, great question. Look, I think as we talked about it and as we mentioned, education does matter the most in this space. I think one of the major sort of reflection that I can provide based on what I see day to day is obviously within the Australian market, everybody is positive and everybody is open and everybody wants to contribute and do and make a decision and take an action with respect to reducing carbon footprint, with respect to becoming energy efficient, to becoming more energy efficient. But I think what I face or sort of experience is that positivity is being diluted in a way that they don't know how to do it and they don't know how to implement it. And when it comes the question around investment, that even is become a bit sort of weaker or become a bit more disappointing that because there is a huge cost involved or it's perceived as the cost in investment is huge, then that positive energy is sort of getting weaker and weaker, and then until clients or companies they don't have to, they don't do it. And I think what can sort of change or shift is that education piece, that first of all not being so boxed down or concerned in terms of the investment amount. I think the investment in some of these technologies in terms of pricing, it's not even that expensive that it's perceived from outside. And I think having those pilots would definitely assist everyone to get that tangible feel and value. And I think the second item around the proactiveness and the education is just like how my fellow engineers and colleagues were able to jump onto these sort of sessions to constantly learn and adapt and sort of investigate and be open to sort of playing with new technologies rather than remaining as a creature of habit and adapting or continuing and repeating the same existing one that has been used as well. So I think these are the two insights that I think I can share.
That's great. Thanks, Malad. Shun?
If if I can add some comments on that, maybe clients, customers are facing the two challenges, which are technical challenges, and another is could be commercial challenges. For the technical challenges, as we are doing the webinar today, and we have our experts in sitting in Australia, we can always get in touch with the clients and show what solution we can provide to specific project or the customer's needs. And we can continue doing that to support the customer's market. In terms of the commercial challenges, obviously these products, that's something you add on to onto the project, which is a cost, additional cost. But how you see this is as a cost or some saving for the future, it's really depending on you. But what we are trying to explain and educate the market is this is a saving for the future. And Milad has touched about that, but we can start invest small, and if customer or the solution is seems working and good, then we can expand because our hardware software has a high scalability with, so we can even start small for the initial investment, and if it works, then we can always go expand the solution, add on more solution to it. So from the commercial point of view, we definitely here to help the customers and their project and their pains.
Thanks,
Very good.
Shane.
And I just can add one more item there, and I think that's retrofitability. So I think the advice that I have there is for my colleagues to always consider the potential that retrofitability can bring in, and they don't need to change the entire system. They can just look into retrofitting to improve and enhance on this path.
I love that you threw in retrofitability. I think it's really important for people to continue down this journey and to be open to new technologies and what that's bringing to the market. And as you guys said, it's not that expensive. It really isn't hard to keep an open mind about different technologies and what's available. Before we do our final wrap up, I just wanted to throw out there, I've been working in the energy space now for coming up to 30 years, and we have made a lot of transition over that time from traditional energy right through to the cutting edge renewables now. But I feel that you guys are really the cool kids in this space. Not only are you working in energy, but you're also in digitisation and how to do cool things in cutting edge space. So you must be very happy working at ABB and on the products that you're developing and what that's bringing to the market. So any thoughts on digitisation? I know it means a lot of different things to different people, but your thoughts, Milan?
Look, 100%. And thanks for noticing that. Definitely looking into the energy space and electrification space from a different angle is the driver that is driving us. I'm pretty sure it's pretty similar for Mr. Shun here as well. The new technology advancement, specifically around the new EV charging infrastructures, around the data center infrastructure, they are all calling out for Internet of Things. They're all calling out for digitalization. They're all calling out for this possibility, which is really a dream for us in terms of being able to communicate from the load transmission to the source And I think that's how we are sort of shifting and traveling at this moment in time. And it's definitely a privilege and at the same time a pleasure to be able to play around and face these challenges of the new technology. So thanks for that.
Thank you. Shun, any last words?
No, Milad said everything that I wanted to say, so that's actually good.
Okay. All right. Well, thank you, everyone. That's all we've got time for in today's session. Please join me once again in thanking Milad Mostafavala and Shun Mizuta for their time and their input. It was fantastic to hear what's going on in the ABB space and what's happening in energy. I'd like to thank Engineers Australia Energy Partner, ABB, for their support. If you could please complete a short feedback form, which is linked to the description box below, to help us improve and future plan our sessions. And I'd like to thank Megan Purdy for her work in helping us today pull this all together. Thanks for joining us, and we hope to see you at our next Thought Leaders event.